Love that music. Thank you very much, Alistair. It's also great to see a big audience. We kicked this event off last year, actually, in Silicon Valley, which was exciting, San Francisco. And I don't know if many of you were there, but that was a very, very interesting event. I spoke there also about sort of the future of electric flight and kind of wanted to take you through a little bit of what I see as the future coming in terms of electric aviation. Now, Alistair obviously talked about this being a revolution, so I thought it important to talk about revolutions in mankind's history. We'll go about 500,000 years back to the first evolutionary tools which Mother Earth gave us. Humans obviously started to invent their own artificial tools. And then it was about 500,000 years ago that led actually to the hunter-gatherer phase, which brought humans up to the top of the food stack. It was about 10,000 years ago, you might call it the invention of artificial farming, that brought in the agricultural age. And then about 200 years ago, the advent of artificial power brought in the industrial age. And people talk about the industrial age in sort of three revolutions. The first was with steam power. The second was the invention of electricity that we're all familiar with. And the third is really the computing and telecommunications revolution. And now people are starting to talk about the fourth industrial revolution. Obviously, with the advent of power, humans invented flight and began to explore flight. This is at the turn of the century. Many were experimenting with different types of flight and powered flight. In fact, there were so many experiments going on at the time that the public actually began to get a little bit frustrated with everyone attempting to fly. And December 8th, 1903, the New York Times ran an op-ed titled, "Man Won't Fly for a Million Years." To build a flying machine would require the combined and continuous efforts of mathematicians and mechanics for 1 million years. Of course, 9 days later, literally, man flies. December 17, 1903, the Wright brothers. And obviously, mankind has been perfecting the original Wright brothers concepts since 1903, all the way through to the largest flying machine, the A380, which, as you may have heard, actually we'll see its last shipment, I think, in 2020. So now people are starting to talk about the fourth industrial revolution, which off of obviously powered the invention of power, and then electricity, and then computing television. We're now seeing what people are calling the fourth industrial revolution. I just want to give you a little bit of a video on that for a quick second.
We are wondering what is happening to the world. Everything is changing.
The very idea of human being some sort of natural concept is really going to change.
Our bodies will be so high-tech, we won't be able to really distinguish between what's natural and what's artificial.
Inside our own heads is the most complex arrangement of matter in the known universe.
You might ask yourself, can we get to be superhumans?
And of course, with the fourth industrial revolution, what is the most important thing that we're going to invent? The Jetsons, flying around. So obviously in the fourth industrial revolution, a lot of people are talking about artificial intelligence, electric flight, obviously the ability to solve cancer in some respects. We're seeing self-driving cars, obviously a result of the electrification of cars. Self-driving computers are actually on the rise, if anybody's ever heard of robotic process automation. And obviously, what we're all here to talk about, and the way I see electric flight really changing, is in urban transportation or mass urban transportation, which has become an increasing problem all over the world in every major metropolitan city. Obviously, there are many projects in electric flight. They include large companies and small companies. Obviously, Boeing, Airbus, Google has a number of aircraft flying right now. And Uber, many of you have heard about Uber's Elevate project. There are over 100 different projects going on right now in electric propulsion and electric propulsion flights. So let's explore how electric propulsion might change aviation as we know it. First of all, commercial aviation today has one major deficiency. It doesn't work for short-range transportation. That's 0 to 300 nautical miles. Now, when I say it doesn't work economically. Obviously, in long-range travel, most consumers fly from 300 nautical miles all the way to 8,000 nautical miles. But for short-range travel, that is mostly relegated to ground transit modes. And there are a lot of reasons for that. One is that runways and airports take up an enormous amount of space. They require runways. Denver International Airport is 33,531 acres. It's an enormous space. It sits on about 53 square miles. Now, if you compare that to New York Grand Central Station, just in terms of footprint and the number of passengers handled, Denver International Airport handles about 58 million passengers per year, sitting on a fraction of the real estate, 44 acres in total. Grand Central Station handles nearly 5 times the number of passengers at 273 million passengers a year. Short-range transport is dominated by ground-based modes, including trains, buses, ferries, and automobiles. And ground-based modes have many glaring deficiencies, as we're all fully aware of. One, they are increasingly becoming landlocked, meaning there just isn't any more real estate to build mass transit systems or ground-based systems or put in new highways. As most of us know, it is incredibly expensive to add another major transit system in any of the major metropolitan areas around the world, particularly the dense ones, like the big cities, London, and so forth. Ground infrastructure also costs billions of dollars to not only build, but maintain. I'm sure you've seen the highways that have been put in place, the rail tracks, but a lot of people don't know how much it costs to actually maintain that. All that infrastructure requires ongoing maintenance, even in the case of rail track. And it's increasingly slow. It's actually an amazing picture of China, but I'm sure we're all familiar with just the density of travel and the slowness of travel. India has problems, the Bay Area has problems, LA has problems. Just about all the major metropolitan areas are just coming to a kind of screeching halt. So by aviation standards, electric propulsion is revolutionary in the sense that it can actually solve the 0 to 300 nautical mile or short-range mass transit problem. It's not really great, as we all know, for long-range transit, simply because the energy density inside of Jet A is about 40 times greater than an electric battery. But for short-range travel, electric has many, many overwhelming benefits. And just to talk about a couple of these, so I don't know how many people know this, but fossil fuels, most of the energy that is converted into forward thrust is wasted in terms of heat. So a jet engine expends about 76% of the energy goes straight out in heat. Only about 24% of the energy is converted to kinetic energy, moving the airplane forward. If you compare that to an electric motor, the energy conversion is incredibly efficient. About 94% of the energy is converted into forward motion or kinetic energy. Furthermore, electric motors are incredibly small and lightweight and not very complicated. They have one moving part. So this is a engine, Lycoming engine, typical engine, 444 pounds, producing about 300 horsepower. Now compare that to an electric motor. This happens to be a Tesla motor, about 70 pounds, actually produces slightly more horsepower, about 350 horsepower. And electric motors are nearly maintenance-free. Obviously, inside of a jet engine or any kind of a fossil fuel burning engine, you have enormously high heats, very exotic complex materials. In electric motors, you have almost no heat expended and typically one moving part. So it is better, cheaper, and more efficient. No oil systems, no fuel systems, no cooling systems. Electric is easily distributed where you need the power, and they're quieter. All of these things are very critical in aviation, particularly in metropolitan areas where noise is a problem. And of course, there's zero emissions, which is kind of nice. So electric is also faster, cheaper, and more efficient. This is a comparison of the energy cost of a typical eVTOL with a train, car, and a bus, and they're surprisingly efficient. eVTOL is about $3.93 for a 50-mile trip. If you compare that to a train, it's surprisingly in range with a train. In fact, in some cases, trains actually have a very inefficient load factor for a variety of reasons because they're going on one track, whereas aircraft can move around. So there is actually the potential that eVTOL becomes even cheaper. Certainly cheaper than a car and cheaper than a bus, but of course eVTOL or electric vehicles are much faster, which is an overwhelming benefit to any other ground-based transit mode. And electric vertical takeoff and landing equipment require vastly less ground infrastructure. This is where you get enormous savings over putting in, say, a train system or a new bus system. eVTOL doesn't require anywhere near the ground infrastructure that you see with current aviation or the busing systems or even train systems. And obviously, eVTOL allows you to fly over metropolitan areas very quickly, so it doesn't really impact the issues that you have in densely populated areas. And they can fly from very small spaces, fractions of the size of typical airports. Over the coming decade, let's explore where this might go. And this is sort of interesting because California just canceled, or mostly canceled, their high-speed rail, if anybody has actually known that. So I'm going to actually put that in comparison to where eVTOL has come and where it's going. So obviously about 5 years ago, we had 1 pound flying, no passengers, but we had drones, which were computer-based and electric-based. Now we have, in the next 3 to 5 years, something can carry 600 or so pounds, 2 to 4 passengers. And over the next 10 to 15 years, it's not too unreasonable that we can stretch that to fly something the size of a bus, or maybe 20 passengers, 20 to 40 passengers in the 6,000 pound range. And what could we do with something like that? Well, in the Bay Area, there's a huge opportunity to put a mass transit system that would allow you to really expand the envelope of where people live. Obviously, most people live in downtown San Francisco, or they work in the peninsula in quote-unquote Silicon Valley. So there's an enormous set of choke points for all the bridges around that area. There is no space to build a new mass transit system. Most of the arteries are clogged. BART is clogged. But if you could fly in about 10 to 15 minutes in something the size of a bus, about 20 to 30 to 40 passengers, you could actually potentially live 75 miles out in surrounding areas. That would dramatically change, particularly if it was efficient, or the cost of $10 to $15. It would dramatically change where you could live around surrounding metropolitan areas. In addition, for long-range travel, another problem is major metropolitan airports. There are about 93 big airports in the United States, believe it or not that many. So being able to put local regions where you could fly directly into SFO in the course of about 10, 20, maybe 30 miles would be substantial. So I actually live up in Napa, California. To get to SFO, even though it's about 50 miles as the crow flies, I count on 4 hours. If you live in, surrounding parts of New York City, you're going to the airport, you're probably counting on an hour and a half, plus the hour that you need to get into the airport and go through TSA. if you could actually get on board an eVTOL aircraft that could carry about 20 to 30 people, you could go directly into most metropolitan airports very, very efficiently. And you could probably board TSA at these local regions. We did a interesting study on comparing such an eVTOL system to one of the biggest train systems being proposed, was proposed 10 years ago, actually passed in California with $30 billion worth of funding. Actually, those costs crept up to about $70 billion, probably on the way up. And in the last couple of weeks, the program's actually now in jeopardy and probably going to be canceled. But let's compare, what we did is to compare a eVTOL transit system on a sort of apples-to-apples basis with this train system. So we put in some extremely conservative numbers into a like-for-like system. So the California high-speed rail is proposed to serve about 24 cities. Most of those cities are between 25 and 50 miles apart. That's something an electric aircraft can fly. And it was projected to carry about 200,000 passengers a day. So we said, okay, what do we have to do to build an electric eVTOL system that can serve 24 cities for similar costs? So first of all, you have to develop an aircraft. We all know aircraft development projects are not cheap. We took as our benchmark the most expensive aircraft development program as of late, or of the largest aircraft, the A380, as our baseline. That was about $15 billion. Then to move 200,000 passengers a day, you would need about 400 eVTOL aircraft that would carry about 40 passengers. We used as a baseline for the cost of each aircraft the similar size regional jet. In fact, we used the 737, which cost about $25 million each. And then instead of 24 cities, we put in 50 cities into our mix. And we put in an airport costing roughly $75 million, or a station costing roughly $75 million each. And when you compare those costs, you get to about 28.7. You're serving twice as many cities for 1/3 the cost, and actually lower electric costs per passenger, and it's green. So that's a very interesting, based on extremely conservative numbers, gives you some idea of the potential of this industry over the next 10 to 15 years. And one other major benefit is that unlike rail systems or bus systems or ferry systems, if you put them in place for manned transit, they're usually along a straight line, which makes the transit system a lot less efficient. Actually, your load factors draw, which means your cost per passenger also go up. Whereas an eVTOL system could actually serve a mesh network of cities, and it also allows you to serve more cities. So you get a much more efficient system overall. So I think we're at a really interesting point in time. Obviously, there are really interesting projects going on in 2 to 4 to 6 to 8 to 10 seat range. I think in the next 10 years, you're going to see projects that are growing in size, meant to serve the mass transit environment in a local or metropolitan area. And I think it's an interesting intersection in time, because you really do have this mass crisis in urban congestion and a potential emerging disruptive technology that can solve it. So hopefully there will be a lot of interesting discussions and topics that come out of this conference, and thank you for listening.
Do we have any questions? Great.
So you estimated about 28 billion or 28.7 or something to get this to all unfold and happen. In the development of the aircraft, your estimate is about 15 billion based on the A380. But as I understand it, there are about 120 companies that are right now vying to become, eVTOLs. And so don't you think that there will be a fair amount of capital that will be wasted at the end of the day, because not all of them will likely succeed? And if so, what's the aggregate amount you think will actually wind up being spent to get to have 3 or 4 different FAA certified aircraft?
You know, it's a really interesting question. Obviously, aviation 100 years ago started in smaller aircraft, and they worked their way up, and we've built aircraft all the way from 2 seats to 800 seats. So scale is not the issue. I think as most of you in the audience probably recognize, the issue is not really getting the prototype to market. The prototype is pretty easy. I think it cost about $400 million in total design effort to actually lay out the 787. It's really the cost of certifying and building the machine to build the machine, so to speak, that costs a lot of money in aviation. So I don't think it would cost $15 billion, but a regional jet, you might spend $3 or $4 billion. And obviously there's a lot of experimentation that's going on now in the small 2 to 4 to 6 seat, which is paving the way for electric flight. Obviously the FAA and governing bodies don't really know how to deal with how to certify these aircraft, so it's important to get smaller aircraft through that system and figure out what's important in electric aviation to be able to certify these aircraft and grow it into a larger transport system. So.
Right. We've got a question from Slido. What is eVTOL's environmental impact versus trains versus cars? And possible casualty rates. That's a nice cheery subject. Passenger and ground crashes due to crashes and preventative measures.
Good questions. First of all, the environmental impact of trains and cars, surprisingly, is not necessarily the driving of the trains and the cars. There's an enormous environmental impact that goes on in just building a highway or building a train system. So the amount of concrete that was supposed to be poured for the California high-speed rail was something in the tune of $15 billion of concrete. Now, concrete and steel takes an enormous amount of energy to produce. So you have an enormous environmental impact before you put your first passenger on any of these systems. Secondly, they're obviously very, very expensive. And third, kind of an indirect impact, is that you have to actually come up with the land to build these things, which obviously takes away land. So in terms of safety record, cars are substantially more dangerous, as most people know, than most flying. Flying is much safer. I think air travel, last year in the United States, we didn't have a single death in the aviation system, at least the commercial aviation system. So flying is substantially, I have a lot of friends who are afraid of flying, and they always ask me, how do you deal with that? And I'm like, well, when you get in a car, it's already something like 100 times more dangerous per mile than an airplane. So if you're afraid of flying, you must be really afraid of driving. So anything that flies is, I think, generally a lot safer.
Okay, we've got two quick questions.
Yeah, Dan Thisdell, I'm a journalist with Flight International, and your answer to this last question shows that you've obviously thought carefully about your earlier remark that the aircraft is zero emission, which clearly it is not. There's a lot of embedded carbon in its manufacture, et cetera, and that's comparative to other modes of transfer. It may be zero emission at the tailpipe, so to speak, but you've obviously thought about that, but I'm wondering if you can look a little further. Are we talking about the right revolution here, and are we talking about a replacement for a system that's clearly failing? I would agree with that ground transport that we have, in that we live in a world where 15-year-olds are boycotting school in order to try to wake people up and force them to deal with the climate change problem. And it is a very short step to your other point that all of this ties into all kinds of other negatives that are associated with, the way we're living. And the point is, can we just change the technology and address these problems, or are we actually at a sort of revolutionary moment when a broader rethink of how our society is organized needs to come into play? And in that scenario, is a 10 to 15 year shift to, significant profitable aviation actually realistic?
That's an interesting question, because if you took out all aviation and its CO2 impact on the global carbon emissions, I think that the numbers are over the next 100 years, it would affect the temperature of the planet by 1/100th of a Fahrenheit degree, according to the IPC. Even if you took out all of the United States or even all of Europe's carbon footprint, it would have a small impact on the temperature change. So thinking realistically, I don't see, electric is greener. I think the better thing is it's zero emissions. It means it doesn't have a lot of pollution in terms of other pollutants that come out of, that are produced by cars and by jet fuel out there. Burning fossil fuels has other pollutants beyond CO2 that are impactful. But I think it's the efficiency and the speed that make the difference. Right now, part of the reason metropolitan areas are so congested is because you're just not willing to travel more than an hour to get to work, right? So that forces you to be somewhere near where you work. But if I could be 50 or 75 miles, something that an electric aircraft, I might be able to live out in the country and get to work in 15 minutes. And that changes substantially the environment of major metropolitan areas, which are highly polluted. So I think it's all the other reasons that make electric aircraft efficient, and getting away from these highly dense metropolitan areas, that would be the major impact on society.